1.5 Laws of chemical combination. The combination of elements to form compounds is governed by the following five basic laws. 1.5.1 Laws of converse conservation of mass. This law was put forth by Antony Lavoisier in 1789. He performed carefully experimental studies for combustion reaction and reached to the conclusion that in all physical and chemical changes there is no neat change in mass during the process. Hence, he reached to the conclusion that matter can neither be created nor destroyed. This is called laws of conservation of mass. This law formed the basis for several later developments in chemistry. In fact, there was the result of exact measurement of masses of reactants and products, and carefully planned experiments performed by Lavoisier. 1.5.2 Law of definite properties proportions. This law was given by a French chemist, Joseph Proust. He stated that a given compound always contains exactly the same proportion of elements by weight. Proust worked with two simples of cupric carbonate, one of which was of natural origin and the other was synthetic. He found that composition of elements present in it was same for both the samples as shown below. Joseph Proust 1754 to 1826. Percentage of copper, percentage of carbon, percentage of oxygen. Natural sample 51.35, 9.74, 38.91. Synthetic sample 51.35, 9.74, 38.91. Thus, he concluded that irrespective of the source, a given compound always contains same elements combined together in same proportion by mass. The validity of this law has been confirmed by various experiments. It is sometimes also referred to as laws of definite composition. 1.5.3 Laws of multiple proportion. This law was proposed by Dalton in 1803. According to this law, if two elements can combine to form more than one compound, the masses of one element that combine with a fixed mass of other element are in the ratio of small whole numbers. For example, hydrogen combines with oxygen to form two compounds, namely water and hydrogen peroxide. Hydrogen plus oxygen gives water. 2 gram, 16 gram, 18 gram. Hydrogen plus oxygen gives hydrogen peroxide. 2 gram, 32 gram, 34 gram. Here the masses of oxygen, that is 16 gram and 32 gram, which combine with a fixed mass of hydrogen 2 gram bear a simple ratio that is 16 is to 32 or 1 is to 2. 1.5.4 K. Lewis's law of gaseous volumes. This law was given by Gay Lewis in 1808. He observed that when gases ga- gases combine or are produced in a chemical reaction, they do so in simple ratio by volume, provided all gases are at the same temperature and pressure. Thus, 100 milliliter of hydrogen combine with 15 milliliter of oxygen to give 100 milliliter of water vapor. Hydrogen plus oxygen gives water. 100 milliliter, 15 milliliter, 100 milliliter. Joseph Louis Gay Lusig. Thus, the volume of hydrogen and oxygen which combine, that is 100 milliliter and 50 milliliter, bear a simple ratio of 2 to 1. Gay Lusig discovery of integer ratio integer ratio in volume relationship is actually the law of definite proportion in volume. The law of definite proportion stated earlier was with respect to mass. The Gay-Lewis law was explained properly by the work of Avogadro in 1811. 1.5.5 Avogadro's law. In 1811, Avogadro proposed that equal volumes of all gases at the same temperature and pressure should contain equal number of molecules. Avogadro made a distinction between atoms and molecules, which is quite understandable in present times. If we consider again the reaction of hydrogen and oxygen to produce water, we see that two volumes of hydrogen combine with one volume of oxygen to give two volumes of water without leaving any unreacted oxygen. Note that in figure 1.9, page 16, each box contains equal number of molecules. In fact, Avogadro could explain the above result by considering the mm, molecules to be polya, polyatomic. In hydrogen and oxygen were considered as diatomic as recognized now, then the above results are easily understandable. However, Dalton and others believed at that time that atoms of the same kind cannot combine and molecules of oxygen or hydrogen containing two atoms did not exist. Avogadro's proposal was published in the French journal de Physique in spite of being correct, it did not gain much support. Lorenzo Romano, Emidio Carlo Avogadro di Curia ed Carito 1776 to 1876. Figure 1.9. Two volumes of hydrogen react with one volume of oxygen to give two volume of water vapor. After about 50 years, in 1860, the first international conference on chemistry was held in Karlsruhe, Germany, to resolve various ideas. At the meeting, Stanislaw Caningro presented a sketch of a course of chemical philosophy, which emphasized on the importance of Avogadro's work.